we have to try to simplify these equations. I remember simplifying, essentially, I think of it as just how can we reduce the amount of ink on the page, or make the numbers a bit smaller. That usually means. So if I've got 42 multiplied by x, y, z all over 56, that is identical to 42 over 56 multiplied by x, y, z. Okay? So if you just want to zoom, if you follow me, you'll be able to read it. I think you might. Can you see it okay from where you are? So basically, you can't simplify the x, y, z anymore, but you can simplify the 42 over 56. You can see that straight away because it's an even number for one thing. They're both even numbers, but you can probably simplify it further than that. So can we start off by simplifying 42 over 56? How would we do that? So basically, we're looking for a number that both 42, or the largest number specifically, that 42 and 56 can both be divided by. And that number is 7. So you need to be familiar with your 5 times table to do that. So if you divide both numbers by 7, what do you get? Well, 42 divided by 7 is 6, and 56 divided by 7 is 8. So that's going to be 6 over 8 multiplied by x, y, z. Now we can simplify it even further because both of those are even numbers, and we can see that's the same as 3/4 x, y, z. So that's that one there. Okay. Now I'm going to jump ahead and look at some of these other ones, and we're going to use the collecting like terms idea. We're identifying like terms at least. Okay, so the numbers, those two numbers were like terms, whereas this x is on its own and the y is on its own. Like there's nothing that can be collected with the y, and the same with the z. Sorry, so they're all on their own. If we go to some of these other numbers, go to some of these other questions though, we've got an a at the top, we've got a at the bottom. And then we've got a B at the top, a B at the bottom, and then you've got the numbers again. So we've got these numbers that can be collected. So with each one, you're looking at what are the like terms. So once we've identified that, if it's just A divided by A, well, first of all, we know that 3 over 3 is 1. And we also know that 4 over 4 is 1, right? So A over A is going to be 1. Anything over divided by itself is going to be 1. So you can basically cancel them out, which means you can cancel out the B as well. And then you've got 45 over 60. I can see straight away that that's 3/4. And you've got the C at the bottom. So that's going to be 3 over 4C. That's B, okay? All right. What about when you've got a like term that, like this one here? Well, we've got x's, but you've got x to the power 7, and then divided by x to the power 3. Well, that's going to be the same as 12. First of all, 12 over 20, we can simplify that. That would be 6 over 10, which would be 3 over 5. So that could be 3 over 5. And then we've got, remember, x to the power 3 is just going to be x times x times x divided by x to the power 7. So x times x times x times x times x, 1, 2, 3, 4, 5, times x. Right? Does that make sense so far? Well, that means that we can cancel out that with that. We cancel out that with that. We cancel out that with that. And we got x at the bottom there. So this is going to be this is going to be equal to 3 over 5 to the power of 4. Oh, sorry. Yeah, sorry, x to the power of 4. Right? Did those three examples make sense? Oh, okay, cool. Right, so what I'll do, I'll stop there and let's see if you can do the remaining questions there.